Welcome to our ECCV submission, HandDGP Camera Space Hand Mesh Prediction with Differentiable Global Positioning. Previous work typically predict hand meshes relative to a root joint, usually the hand wrist. While this is often enough for some applications that only require good hand projections in the image as shown in the video on the left, it is not enough when we want to interact with virtual objects while using our hands, as shown in the video on the right. Most state-of-the-art hand mesh prediction methods predict hand meshes that look reasonable on the projected image. However, let's take a closer look on what happens in the 3D camera space. In this particular frame, we observe that the 2D projection of the hand is good. However, if we plot the hand prediction in 3D, we observe that the predicted hand has a significant error and has a visible offset from the ground truth. In this work, we aim to predict 3D hand meshes that not only look good when projected, but also are more accurate in the camera space. In blue, you can see our predicted hand mesh, which is closer to the ground truth in 3D space than Mobricon, a state-of-the-art approach and the main baseline of this work. To produce 3D hand meshes in camera space, previous work typically predicts meshes relative to a root joint, and then lifts the predictions to 3D in a subsequent independent stage. However, because all learning usually occurs in the relative space with close-ups of the hands, the more global camera space context is often lost at this stage. In this work, we propose to do the learning in the camera space by proposing a new differentiable global positioning function that enables the back-propagation from the camera space to the input. This module and an image rectification step that harmonizes both training and test images as if they all were captured by the same camera, allow the network to take into consideration more 3D context cues, which may help with overcoming 2D to 3D ambiguity. Our framework builds on top of Mobricon, which consists of an encoder-decoder method that predicts 2D hand key points and 3D relative meshes in a local frame that are lifted to 3D at test time by an optimization function. Here we show an overview of our method, which enables the end-to-end learning of camera space predictions. Our framework is flexible and agnostic to the root relative method of use, as it can be applied on top of different relative mesh methods as shown in the supplementary material. We invite you to check all the technical details in the paper. We show that our proposed method outperforms several baselines and state-of-the-art camera space hand mesh methods on different datasets. We also present qualitative results in the paper. Here we show a qualitative video where we compare against camera space state-of-the-art methods on a HO3D dataset sequence. We observe that our method predicts better 2D hand mesh projections than our closest competitors. We draw similar conclusions in this other sequence. We note that the hand mesh prediction is hard, particularly in the presence of object occlusion and challenging viewpoints. If we take a closer look in 3D, we observe that our camera space 3D predictions are more accurate than both Hassan et al. And Mobricon, thanks to our DGP module and our image rectification. Note that Hassan et al. Also predict object poses and assumes the knowledge of object model, which may help to reduce scale ambiguity. We encourage you to check our paper and supplementary material for more details. Thank you for watching.